let's try actually writing a command that utilizes the library. So I'm going to do img equals image new and RGB, okay, close those quotes, and then 10 by 10. So what I'm going to do is I'm going to create an image file, and I'm going to refer to it as image, right? I've created a variable called image, and inside of there I'm putting in this new image that I've made. It's in the red, green, blue color format, and it's going to be 10 pixels by 10 pixels large, all right? That's what I've just done. Now if I run this, does it get angry? Now I've run this, right? I've run this, and I've created an image, and I've stored it into here. And you might be saying like, okay, well I ran it and I don't see anything. You're right, you don't see anything. I created an image, I've stored it in this, and then I did nothing with it, and the program finished and it's gone. Right? It forgot about it because I didn't do anything with it. I just created it and it was like, whatever. Okay? So what I need to do is I need to actually save it so you can see it. So I'm going to go ahead and save this. And I'm just going to call it test.png. Now if I run this, see what happened here? Now we have test.png, and if I open this, we've got a black box. Not exciting, but it worked. All right, so a couple things real fast. As we talk about this, it does not matter what I call it. All right, I could call this tacos example, or it doesn't matter, right? It doesn't matter what I call it. The other thing is it doesn't matter what I call this either, right? A lot of times when we start getting into some of this programming, students think that like, oh, this has to be img, and this has to be whatever. Not necessarily, right? I have made a variable and I have put this image object in it, right? Again, it doesn't actually matter what this is called, right? This could be Fred, okay? As long as I am consistent and wherever I have called Fred here, I match it up for where I want to refer to it. That's what matters. This is a variable and I'm doing things with the data stored in that variable. Calling an image Fred that is just a black square doesn't make sense unless I'm going to draw Fred, okay? But that's the idea, right? So we often will call it img or something like that, right? It doesn't really matter as long as we are consistent, okay? Now what can I do with this? All right, so if I'm drawing an image or I'm making an image, maybe I want to make some color in it, okay? This is different than processing, okay? This doesn't work with the shapes and all that stuff the same way. It's not built around that. It's not focused around that. This is more focused around processing images, so it's not so much about drawing, but I think it's a good place to start, and we can talk about some different concepts while we do this. And you could also incorporate some of this into working with images when we get to that. So later we'll import images and modify them and stuff. Anyway, how to draw a pixel. So now I'm going to say image. I'm referring to this variable. The name doesn't matter, right? As long as that's consistent. I'm going to say image dot put pixel, okay? And then this is going to be the position. So I'm going to do 1, 1. Notice it's in its own set of parentheses, right? And notice this was also in its own set of parentheses, right? So these are tuples. We've mentioned tuples before, just briefly. We're using tuples. And now we're going to make another tuple, and this is going to be the color value. This is in 0 to 255, okay? 255 is the max, and 0 is the minimum, so this should be white. Again, this is red, green, blue, and right here, RGB, right? I'm in RGB mode. Okay, so now if I do this, we have example, and we've got one white dot here, located at 1, 1. Now you might say, like, isn't 1, 1 here? Remember when we did the ducks and we talked about, like, computers like to start counting at 0? Yeah, they like to start counting at 0. If we change this to 0, 0, now it's there. All right? You could make pixel art like this. All right? You could choose the different positions in there. You could choose different colors, and you could do that, right? So then we could say, okay, so 0, 0 is there, and then what goes at 0, 1, right? What goes at 0, 2, right? What goes at 0, 3, etc., right? And you could create pixel art like this. Now, there are 10 rows and 10 columns, right? Because we have a 10 by 10 image. And if I were to do this like this would take 100 lines of code. And that is not efficient. We can use things like loops and conditionals and stuff like that to make this more efficient, right? We don't have to define 100 pixels. We can do other stuff. And that's what we're going to do, or at least play with a little bit. And you might say, well, like, why? Why would we do that? Okay. And that's totally valid. Totally valid. What I want you to look at, download, allow, okay, download, allow. All right, so if I look at both of these, okay, 79 bytes for this PNG, 217 bytes for that .py file. That is not efficient, okay? But what if I wanted this to be 1,000 pixels, okay? And then if we were to look at that, and now we are to download both of these, download, depending on what we're doing, 3 KB, that's kilobytes, that's 3,000 bytes versus 221 bytes for this .py file, okay? So we have lots of memory now, we're used to lots of memory, right, on these computers, but that wasn't always the case. Depending on what you wanted to do, sometimes you didn't have all that space. Now, 1,000 by 1,000, that is a bunch of lines of code. And again, if we were to do it this way, that would be terrible, and the file size would be huge, right? PNG would be way, 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 way more efficient, okay? But what I want to bring up, what I want to talk about, what we're going to look at, Mario 1-1, okay? Mario 1-1. Okay, so this level, if I can find it, all right, there we go. Okay, so we go this way, we go this way, we go this way, right? Like, this is a pretty big map, okay? If I were to download this, download linked file, okay? That's a web page. If I were to download this, and we look at the file size, all right, 51 kilobytes, 51,000 bytes for this image. Now, is that actually accurate to the way that it would be if it was directly on the original Nintendo? Probably not, right? Like if we actually had like the technology at that time and we saved it as an image file at that time, would it be that size? Probably not, but it would still be a decent size. Now, if we look at file size of Super Mario Brothers, the original game, the whole game itself was only 32 kilobytes. And what did I say level 1 was right there? If that were accurate, if that was how it really started, level 1 by itself is larger than the whole game if you're storing it as a PNG. So instead of doing pixel by pixel, what we could do is we could use like loops and conditionals and stuff like that, right? So I could say for x in range, I guess 1,000, all right? Because what I'm gonna do is I'm gonna make a sky, and I'm gonna make some ground, okay? So Mario level, lots of sky, a little bit of ground, okay? So for x in range, 1,000, so it's gonna do this 1,000 times, and then I'm gonna say image, put pixel, yeah, do that. And I'm going to say x 0, okay, and actually that needs to be a tuple. So we've got that tuple inside of here, we do a comma, and then here we're going to do the value. Okay, so what's going to be the sky color? I don't know exactly what the sky color was from Mario. I don't really actually care, but this will give us a light bluish color. I can always modify it later, right? Now if I run this, all right, we've got example.png. If I click that, we've got this big blue, well, this little blue line that goes across the top of this big giant black square, right? And again, if I download and I download, okay, the example is 3,000 kilobytes. My code that will create the image is only 169 bytes, right? Significantly smaller. we can write code that will make images that are smaller than an actual image would be. And this is what they did, right? Not like this, but you're getting the idea, hopefully. So now you might say like, well, that's great. You've got one blue line. Yeah, I know. Okay. So what we're doing here, the x value, yes, the x value, all right, is changing as it goes through this 1,000 times versus starting at 0, right? That's that first little dot there, right? Then it goes to 1, right? Because it's going to do this 1,000 times, right? 0, the 0 goes there. It does it 1 time, the 1 goes there. It does it 2 times, the 2 goes there. It does it 3 times, the 3 goes right. So it's going to do that each time, okay? And that's how it's drawing it across the screen, right? And this is similar to when we did the Vasarely inspired piece in processing. So now, if I want to make blue go down the screen, what I can do is I can say for y in range 1000, right? Now it's going to do this for each y value as well. So it's going to do this a bunch of times, right? 1,000 times 1,000, right? Because this loop here is inside of this loop. So this loop will run 1,000 times, and then this loop will go once more, and then 1,000 times, once more, 1,000 times, once more, 1,000 times, and so on. All right. So now to make this work, we need to do this as y. Okay. So now it's going to borrow the x and y values. It's going to borrow them from whichever loop it's in, across both. Okay, and it's going to draw those pixels across the image. So now if I run this, we should get a giant blue square. All right, so now if we go to example, did you do it? Did you run? Are you still running? Are you taking that long? It might be taking that long because this is a very... it timed out. My image is too big. All right, let's do 100 by 100. 1,000 loops 1,000 times is just too much. All right, we'll run that. It should be okay with this. Did you finish? Are you done? Are you done? It is. All right, there we go. Now I have a giant blue square. Okay, what I could also say is I could say things like maybe I don't want 100 because it's going to be like I don't need the whole screen, right? Maybe I want some ground at the bottom, so I could say for y in range of 80. All right, do that. And now I need 20 more pixels of whatever, right? If I run this, that'll be black at the bottom, right? Now, 20 more pixels of a grass color. So for this RG, this one's going to be green, so I think I'm going to do 200. I don't want it to be too bright. That might even be too bright. And I'm going to say no red and no blue. I'm going to make this 150. 150? No, 150. There we go. Okay. Let's see how that looks. Oh. What did I do? I forgot to change. I told you what I was going to change it to, but I didn't actually change it. Okay. So now if I run this, a little better, but the grass is way up here. Okay. I want the grass down here. All right. So keep in mind that I'm still using the same x and y values. So it's starting at the top. Right? Because it's going to go 0, 1, 2, right? Because 0, 1, 2, 3, 4, 5, right? And so it's starting up here. If I want it to start down here, I want to move this baseline down here, right? I can just say y plus 80, and now that second one is going to start down here, right? There we go. Now I've got some grass, okay? And I could just keep going with that, and I could start drawing different things, etc.